Welcome everyone to my third session this year. It's the most high-level one, I guess, but I think these catchwords have caught your attention. I'm going to talk about domain-centric and why hexagonal, onion, and clean architecture are answers to the wrong question, and which one to ask instead, or what to ask instead. My name is Oliver Rothbaum. I've been working in the Spring engineering team for the last 15 years. Have been working on Spring Data for quite a while and moved on into more architecture-related stuff. While preparing this talk, I actually realized that this slide is the one that I usually start my talks with these days. I mean, the Modular one just a couple of hours ago was an exception probably to that. But this is kind of like what my work kind of on a meta level centers or is kind of revolving around, right? So it's that like most of our attention or most of technology attention, like if you see how like folks market new technology, most of our attention is focused on that. Like, how do I create something quickly? How do I vibe code the next big thing in 5 minutes? Look what I can do, right? Like, who is lucky enough to have their work week centered around these kinds of activities? For the recording, there's literally nobody raising their hands, is there? Like, maybe one or two. So most of our work goes into these activities, right? Moving existing software onto the next level. And there's a talk by Kent Beck from Domain-Driven Design Europe a couple of years ago that's going to kind of also shape what I'm going to talk to or tell you in the next couple of slides. And he says that there's literally only two activities that we do to software, or two goals that we have when we change software. One is to either increase the value of the software or to reduce the cost, right? So there's nothing more than that. And then the question comes up, or he kind of iterates and comes to the point where he says that literally the overall cost of software is the cost to change it, right? And that's why we kind of have to make sure that we write software in a way that it's easy and thus cheap to change, right? That insight is not really his own, but like derived from a book from the 1970s, the Fundamentals of Discipline of Computer Program and System Design from Larry Constantine and I forgot the other guy's first name, Jordan. What I found interesting, I ordered the book when I saw Kent's talk, and I thought, okay, I would like to read up on the details and all that kind of stuff. And guess what I found in there, from 1997, references to Conway's Law. That was kind of unexpected because I thought that would be a thing of the 2000s and every microservices talk in this world, but no, it predates even that. But so we say that we assume that the cost of change is roughly the cost of software. Then, like, what constitutes the cost of change? And that's a definition taken from the book actually, and it's coupling. Like coupling between the individual elements of our code base. And this is literally how Constantine defines coupling in the book. It's like, okay, when we need to change one element of our software, we also need to change the other thing, then these two elements are coupled, right? So that's kind of like, if we just like abstractly visualize that, we have like our elements in our code base, our classes, our packages, what have you. They are all like related to each other. There's some relationships wanted, some are unwanted, some are intentional, some are accidental. And we actually start to change this thing, and then we realize, oh, to actually complete this change, we have to change the other thing, and then yet another thing, and yet another thing, and yet another thing. Then literally the node in the upper left is indirectly connected to the nodes in the lower right here, and that's actually that's actually causing the cost, right? The distance between the elements and the length of the path here. That said, not all coupling is born equal, because as there are a lot of like tools and in which you can kind of gather metrics, statically analyze your code base, and it will like, oh, this code is more coupled than other pieces of code. But without knowing the nature of the change, you can't really tell whether code is coupled, right? So let's say we have our application code base separated in, let's say, hexagonal architecture style, and we have all the adapters nicely separated from our business code. Then the requirement to switch from JDBC to, I don't know, MongoDB means, or we can actually change that code without having to touch our business functionality, right? So in that regard, that the business functionality is not coupled to our decision to use JDBC or JPA in the first place, right? So although the code is related, I mean, we're calling methods on interfaces that then somehow end up in a JDBC-based implementation, the code is not coupled from that regard. But if I go ahead and say our registration process needs to get a new form field added, right? Then all of a sudden, our DTO to receive the request needs to be touched. And for that, the input data to be processed and verified and validated correctly, our service class has to be adapted as well. And we have to add a new field to the database. So all that code is all of a sudden coupled under that particular change. So it's not as easy as it sounds in the first place, right? The second problem is, so if coupling is the problem, what do? We decouple, right? But unfortunately, decoupling has its costs too, as you probably remember from the path. Like decoupling basically means introducing new nodes in which we can then probably invert some of the arrows, right? But at the same time, it's like more abstractions. It's more moving parts that we have to get into our head, and it's not without cost either. And the most surprising thing that took me a while to get to was that to understand that cohesion is actually coupling too, right? Because a lot of that's why I'm kind of iterating on this quite a lot. A lot of people are like, oh, our code base is too coupled and we need to decouple things, right? So everyone is focused on removing the coupling, and we're going to see that not focusing on cohesion is leading to certain problems as well. And if you look at it positively, then cohesion is coupling in the right places for arbitrary definitions of right? So that's kind of the thing that we're going to get to. So to summarize all of that, any kind of software design activity is actually the act of modeling units of strong cohesion that are loosely coupled to each other. And we actually have to do that. There's no way around it. It's like weather. Yeah, you cannot have no weather. That's not gonna work. So let's say we face a situation like this, right? An arbitrary sea of classes, types, methods, what have you, whatever level of abstraction you want to apply that thinking to. Our goal is to find reasonable groupings of elements. And of course, I cannot tell you what these groups are in your case, but the bet is, or the idea is, that we find the groupings in a way that when we start a change at some point, the effects of the change or the consequences of the change stay in these groups. Right, sorry about that. Right, that's kind of the high-level goal that we need to apply. And we're going to see how our certain architectural approaches actually help us getting there or not. Right? So to summarize all of this in one sentence, it's kind of, I think, a Mastodon post. What we actually do when we design software and when we create these structures in our code bases is that we create a formalized bet on the changes that we're going to see in the future. Right? So this is not all of it, unfortunately. Let me just quickly try to, where this is going. Here we are. Where am I here? There we go. Okay, so this is not all of it, because these units, the circles here, they do not exist on their own, right? So they don't exist in isolation, because if they existed, they wouldn't even form a system. There is a very famous systems thinker, Russell Ackoff. Who has heard of Russell Ackoff? Definitely search some YouTube video from him. Russell Ackoff, a theory on system design. It's like a 5-minute talk, would probably be a TED talk these days. But in this talk, he coins that phrase that you've probably heard in some variety already, right? So the system is never the sum of its parts, but the product of their interactions. So sum versus product. So there's more gravity to it, and the interaction is important. So something like this is not a system, really. The individual things are systems, but we only get to a system when we connect the cohesive elements that we formed back together in a loosely coupled way. Right? That's kind of the pretext, and I hope we find a way around, or just a fundament to what's coming next. This one here. Enter the early 2000s, and something that I call separation of concerns architectures enters the scene. The first of them was hexagonal architecture from 2005, coined by Alistair Coburn, and it's been popular or become popular under different names. I mean, the hexagonal thing is kind of a bit of a misnomer, because he just needed some name in some form except layers, boxes, and what have you. So it's actually a ports and adapters, as he calls it. And the fundamental idea, and you're going to see that it's kind of translating through the other approaches as well, is that we have our business logic contained in an application core, and surrounded by adapters that carry, quote unquote, this functionality into different technologies, right? So we have adapters for databases, for the file system, maybe for some HTTP endpoint, some messaging, or even third-party APIs, and then there's probably some gRPC or whatever underneath. And the fundamental idea is that we have so the dependency goes from the outside in, right? So the adapters implement explicitly designed ports. So some elements of our application core are going to be designated ports, and the application adapters either refer to them, these so-called primary or driven adapters, that reach out to application functionality through these ports, and the driven adapters or secondary adapters are actually implementing the ports, right? That's kind of the fundamental idea, right? So for outside in, and we have a dedicated kind of API between the worlds. 2008, Onion architecture enters the scene, and it's kind of similar. I'm not really sure whether Guillermo and Alistair have known each other before that, but fundamentally the idea is the same. We have our domain, right, or core. There's an application ring, so basically this distinction made here is that there's some abstractions that are core to to our domain, to our business logic or our functionality, and some ideas are like application specific. So we do something. An order is not just an order, but it's processed and what have you, right? And the third ring is the infrastructure ring. So again, we have everything that touches databases, exposes APIs on the outside, and we also have a directed dependency from the outside to the inside. Again, so that the business functionality or business logic doesn't depend on anything technical, really. So when I studied these things, I was like, okay, that sounds all pretty nice and great, but when you think about, like, I started building Spring applications in mid 2006 or something. So when we did this, like the usual way you constructed a Spring application was like, there was some web application, so you write some controller class, and then you have another class that is a service, and then you take an instance of that class as a constructor argument, and you do that turtles all the way down with the repository into the service and the data source into the repository, so you connect these things together. Right? And this looked like, before all of these separation of concerns architecture, this really looked like layered architecture, right? So we refer to one of the other. And then you read books and it's like, you probably want to introduce interfaces for these kind of things, right? So that you're not directly referring to the classes, so that they're easier to test the arrangements. So if you introduce interfaces for the service and maybe the repository, you basically get what you have with a hexagonal architecture, right? Your controller is your driving adapter, and then there is this service interface that's kind of the primary port, and then the secondary port being the repository interface, and then back in the days you manually wrote your repositories, manually implemented them. So that's kind of that. And if you just take off your hexagonal glasses and turn on the onion glasses, then well, it's kind of the same, right? Isn't it? So and if you look at that from a layered architecture point of view, right? So the layered architecture is you have your layers, and then it's top to bottom, arrows top to bottom. Even that's sometimes surprising for people from the domain-driven design space. Even Eric in domain-driven design basically describes layered architecture. The business is depending on the persistence, which is something that if you meet, like, let's say, more modern DDD enthusiasts, they were like, never, right? It's not going to happen. So if you think of hexagonal and onion architecture as derivatives of layered architecture, then you basically get two things. We change the direction of one arrow, and we insist on interfaces. But it's actually nothing more than that. Spoil the secret. All right? So that's kind of it. So every time I read the books, I read the blog posts about onion architecture, and it always left me a bit underwhelmed of like, okay, so we use interfaces and dependency injection, and that's an architecture now. Well, okay, that's fine. So you can, if I'm of course joking a bit and I'm exaggerating, looking at it from like 15 years later. Why did both Alistair and Guillermo come up with this stuff then in the first place? If it's actually not that like you could argue innovative, right? You have to remember, early 2000s, we were actually still deploying code bases to application servers, right? People were using EJB and Xdoclet and all this kind of stuff. So all the technology and a lot of especially the enterprise technology space was like littered with technology that really made it hard to actually test your business functionality without bundling some file and throwing this into some application server, getting 2 cups of coffee to get them started, and then wait for that thing to run. Right? So testability definitely was a problem. But you could argue that with dependency injection and interfaces, you get that. In fact, one of the core premises of Spring, go out to Rod is still probably around, but the thing that made Spring so popular was that you could just by the fact that you were using dependency injection, not even the container dependency injection, but writing the class in a way so that it could be used with dependency injection, made the class unit testable. Right? You hand in the mock or a stop or whatever your preferred replacement strategy is, and you can write unit tests for that logic. Right? The Spring test integration, test context integration framework allowed you to bootstrap an application context on your machine, right? No need to deploy that thing to your WebSphere or what have you. Right? The other aspect was that we want a technology-free domain. So the fear that's addressed by both hexagonal and onion architecture is that we tie ourselves to a persistence mechanism, and then what? Right? Then along comes your customer and argues, "Oh, we need to move from JPA to MongoDB now." And then, "Oh, well, we have our adapters, and luckily we can just basically exchange the data access layer." Has anyone ever tried to do that? For the recording audience, there's a bit of laughter in the room, right? And what's so like weird is, I'm looking for a better word, but what's so, let's stay with weird. Weird about this discussion is like what is a technology-free domain model? I mean, we write this stuff down in Java or Kotlin. It's not technology-free, right? Before we had a decent date time API in the JDK, if you were using Joda time in your domain model, does that violate that principle, or did that not? Right? Is a JPA annotation, I mean, it's coming from the Jakarta.persistence package, right? Is an annotation a violation of that thing? I mean, you can still test an entity class, right? You can unit test a class without JPA on the class path even. So our previous goal is actually not violated by that. So it's not something, there's no black and white, and of course decisions have to be made, but it's not that like the technology choices we have these days are as invasive as they might have been in the early 2000s. So my biggest pet peeve, domain-centric, right? I call these things domain separation of concerns architectures, but like most of them, you hear the term domain-centric quite a lot. What does that mean? I mean, it probably derives from the fact that, and there's some truth to that, the domain is in the center of the image. The same for hexagonal architecture. But what I think is like problematic about that is the primary concern you have when you write a new business application is exactly decomposing that domain. And there is no decomposition. There's no talk about anything about that. No guidance, no help with that. The domain is just that opaque thing, and I often get this like, oh, yeah, this is the thing we don't have to care about, right? We just write adapters and ports and what have you. So everyone is really, really enthusiastic about the technical decomposition. But yeah, acquiring domain knowledge, if I can avoid it, maybe not, right? And that's why I ultimately think if like decomposing the domain is the problem we need to solve, and our primary architectural approach doesn't cover that, it's like ultimately the wrong thing to put at the center of attention. I'm not saying it's like a wrong thing to do per se. It's just that, oh, there's actually something else we need to do before we even go think about onions and hexagons, right? I told you to put on the onion glasses, right? This is because we're going to cut onions next, right? And there's tears involved with that usually. So one thing that I was like suspicious about was that, okay, if there's no decomposition strategy, that can only mean if we have like multiple parts of our domain, multiple domains, so to speak, right? We have our order part or inventory part. Like, how does that fit into that picture? The only thing that we can do is like put one onion next to the other, and then what does that mean for the interaction of these two parts of the system? Do we really need to go through the application ring, through the infrastructure, and then through the other onions infrastructure ring, what have you? And as I said, onions can be cut, right? Why not do that? So slice off the left and the right side of the onion, and what you get is rings that leave some surface, right? So the application ring has the surface to the outside world, which means that we can actually put more of these sliced onions next to each other, and then wrap a box around that, and then each of the sliced onions can actually expose either events or, in Spring terms, beans, which means instances of code that other parts of or other sliced onions can refer to. And that's what we basically, I call this sliced onion architecture for just for the sake of fun of it. But what this brought me to was that in the end, when we're at that point, it doesn't really matter anymore what's inside the slice, right? Because what we're actually interested in is vertically shaped, domain-driven, not necessarily in the domain-driven design sense, but like domain-driven, whatever, slices, right? This is kind of the thing that we want to get to. And one of the reasons being that whatever goes on inside these modules can actually be totally driven by the complexity of that individual slice, right? When all I have is one of these, let's say, modules is just like I need to read some data from 2 database tables, and there's got to be some, I don't know, JSON endpoint, HTTP endpoint that returns some JSON. If that's all it needs, why would I go ahead and have my adapter and my port and my what have you? I could just wire a bloody JDBC template into a controller and be done with it, right? I mean, seriously, that's like what I would do in this case. And if you use and can use the encapsulation functionalities of whatever module system you use, then you basically can switch to a, let's say, more sophisticated internal decomposition whenever need arises. All right, so much for the technique or the high-level discussion. Let's talk about code and the way we lay that out, right? So what's going to follow is highly inspired by Simon Brown's work. We've had some exchange over that at a couple of conferences, and I've slightly tweaked some of his graphics here and to make my point better. It all started with I was returning from a customer engagement in Stuttgart one day, and was realizing it looks like every time I come to a new project, it looks like I can identify the book that the architect just read most recently, right? Because that's like you get some ideas, you read about like hexagonal architecture, and then for some reason, and totally understandably, these architectures come up with basically terminology that you then want, of course, to see in your code base, and that's why you create packages that are named adapters and ports and what have you, right? And that's how these books, quote unquote, reflect into the code structure of your projects. So when we start with layered architecture, it's just a quick second for you to digest the legend here. So we're going to see packages, or they could also be build modules. For the discussion, I'm going to make this. It's not going to be a big difference. Interfaces, classes, and a couple of relationship types. So a classic layered architecture projected onto a file source tree would probably look something like this. So we have our application. Then there is a web package that has order controller plus all the necessary other things. We already introduced interfaces here for the service thing, and then there's some persistence thing going on, and we actually connect them from the outside or from the top to the bottom in this case, right? That's classic layered architecture. So, and this usually without any kind of, or that's the way I've seen this kind of stuff evolve in customer applications, or any application that I kind of looked at, is that when we enter a new domain concept, we basically replicate the division and then have that in the same package. So you have a customer repository next to the order repository and yada, 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 right? And mostly because of consistency, and we want to make it easy to join a new project, we kind of replicate that even further. So what's the problem with that? I mean, there's some decoupling going on here with interfaces and what have you. The problem is that we have units of encapsulation are packages that we do not use to actually encapsulate things or to create cohesion, right? Everything order related in this case doesn't have anything to do with the customer things. There might be, let's say, there's interaction between, let's say, the services. Fine. So let's say the order service reaches out to the customer service interface. Fine, that could be it. But in most cases, the controllers don't have anything to do with each other. The repository implementations don't have anything to do with each other, except they are probably all JDBC implementations. That's a bit like the comparison I usually make is that when you at home, when you go to your partner and say, hey, let's have all the chairs in one room and all the tables in another and all the closets in a third, right? That's incredibly helpful if you spend most of your day answering the door if someone comes saying, I need a chair, can I have one, right? It's easy for you to find these things, which is also why a lot of developers actually go with these kinds of structures. But it's not really helpful if you want to have friends around and have dinner or what have you, right? You need to bring the things together that together create a bigger whole and actually serve some higher purpose. We're going to get there in a second, right? So the low cohesion thing. Now, we didn't want to do layered architecture anyway, right? We do hexagonal architecture or onion architecture. So let's repeat the exercise, right? We change the arrow and move the interface around. So did that solve our problem? Not really, right? So we're not actually creating any more cohesive elements, right? This is kind of, it's the same but different, right? And it's not actually serving that higher purpose, unfortunately. So what to do instead then? One thing, I mean, that I've been advocating also through my work with Spring Modular is that we do away with, not really do away, but we start using packages. I mean, they're a language feature and they have encapsulating functionality, so we can actually use them as such, right? So we could put the very same arrangement. Let's do hexagonal architecture, and put all of the classes inside a single package. So okay, isn't that the same? Like, what's the benefit of all of this? Right? It's still like as complicated as before. One of the things that makes this better than the left two columns is that we have fewer things that we need to expose. Right? So in the dark blue elements are elements that need to be public. And in both cases, we need the order repository to be public, which means that any other part of the code base could actually bypass the service interface and invoke that because it's technically public to the JVM or to the compiler, really. Right? And we can avoid that. And only if we have other functionality that we might have or might need access to, like let's say in the order modular order column here, we can actually make all the types package private, so nothing needs to be known to the outside world. And even for the customer slice, we can go and make only the interface public. Which is, again, we're back to the, remember the sliced application ring where we had this bean exposed to the other modules? That's kind of the way we roll right now, right? So again, and I mean, you see there's like a lot more, there are a lot more internal dependencies. There's a lot more cohesion in these elements than there are external dependencies. If you rethink this as that's where I was trying to get to. If you rethink this as these columns, we explicitly move things to the edges whenever they are actually needed. And to reiterate on that, we can also it also doesn't matter like what the internal structure really is, right? So to the outside world, it just looks like it's just a module, quote unquote, right? We could do weird things, and I think I've hinted at that, right? If that vertical slice, the functional unit that we're working on, doesn't really need all this kind of separation, we can just go ahead and put the JDBC operations into the controller. And don't tell anyone, right? That's it. All right. So just to close out on this, our goal is to create these kind of shapes in our application that allow us to contain the changes that we need to make inside these units of code elements, basically, right? So our primary objective is that we need to support the changes that we face regularly, and usually that's new features that add some kind of value to your system, and that require you to change the entire arrangement, right? So it's hardly ever is it the changes or is it changes that only affect, let's say, only affect the infrastructure ring or only affect the domain, at least in my experience. So, as general strategic considerations, favor functional decomposition over technical decomposition. That's kind of the thing I'm trying to make. There's nothing wrong with hexagonal architecture, nothing wrong with onion architecture. It's just not the first question that you should answer, really. Intrinsic complexity determines accidental complexity. So how much machinery we actually need is determined by our vertical slice. I can totally relate to the fact that you want some kind of consistency in the design of your applications, and I often see that that's exactly the case why teams decide, oh, we do everything in hexagonal architecture. Was someone in Victor's talk yesterday about the psychology of code? He had this example, right, of the architect forcing someone to do this to their microservice, and they were like, oh, it's just a simple thing, I don't need to, but yeah, right? So that's kind of the idea here, right? The more complex the domain, let's say you have a, I don't know, vertical slice that deals with payments, right, with third-party APIs, what have you, in such cases it's definitely worthwhile to add these adapters and create some kind of abstraction in front of them. Encapsulation over organization is also something that Jos mentioned in his talk this morning on Spring Modulith, right? We have language features that allow us to hide things from other things, and we should use them, right? You're not like declaring public fields everywhere. You should not declare public classes everywhere. We have these means and we can actually use them. There are some shortcomings still, like with the Java package system actually, and there's like other tools like the Java module system and Spring Modulith that help you like on a slightly higher level. But that's like whenever you try to shape something, design something, then have a look at, like, is there a way to actually hide things from the outside world, right? I mean, that's the fundamental idea of modularity, to encapsulate decisions about how we solve certain things, right? To reiterate, I have like one more thing for you, to reiterate on the chairs and tables analogy, right? I mentioned that I can totally understand why developers go ahead and like create these stereotype packages, right? My controllers, my services, my exceptions, what have you, my annotations. There is, and that's because we want to relate to these concepts. So our mental model is like when we decide to use DDD, we think in aggregates, entities, value objects, what have you. When we use hexagonal architecture, we think in adapters, in ports. So we think in these terminologies, and that's kind of the way we shape the way we look at our code base. And our IDEs present these abstractions to us in exactly that way. I briefly have to wait a second. We need to try that. What's that doing? Yeah, probably. Does that work? Does work, right? So the way that our IDEs present a project to us is 2 feet above the file system, literally, right? So I can zoom in a bit. So for a Java project, we basically, our IDE knows, probably it knows that it's a Maven project. So we get like the source folders grouped nicely here, right? And it also knows what a package is. So we get folders like collapsed into these nodes, right? And that's basically the way we get our code presented, and that's how we are used to actually interact with these things. And if I need to find, where is this bloody controller? Controller. I probably find a package controller, and that's what brings us there. So what if there was a way for us to get our projects presented to us in that higher level of abstraction? So if we could go ahead and without even having to bother where the files are actually located, we could find all the controllers of a certain scope, right? Find certain bubbles, certain green bubbles in these green rings, right? And that's what the Spring tooling team has actually worked on. And there's a bit of I haven't mentioned JMolecules really in this talk, but there's a Java library that allows you to annotate your code with, or classes and methods with their actual role within the overall system on that higher level of abstraction, right? So there are annotations that allow you to say this interface is a primary port, or this package contains all the code that belongs into the application ring, or hexagon, if you want to, right? And once you have that information in the code, the IDE can actually reason about these higher level elements and can basically present the project to you in exactly that regard. That's what you see here, right? So you have this RESTbox project, like a sample project I used to showcase a lot of Spring technology, and it kind of knows, without going into any kind of detail about Spring Modulith, but ultimately these immediate sub-packages like core, dashboard, drinks, engine, order, what have you, and payment, they form the base packages of the logical units of the modules. And that's what you get displayed down here, right? And for each of these modules, we can now go ahead and find abstractions that we have put in the code base that are like the actual package and the location doesn't matter anymore. So here's the attribute converters that we find. Here's some primary adapters. So there's some assignment going on in the code base that say, okay, here is a method in the dashboard that's an event listener. Here's a request mapping / statistics, and here's an representation model processor, totally irrelevant what that actually is, but this thing is using hypermedia in its REST API, and Spring HETIOS has this concept of representation model processors. That's a good example of technical abstractions mixed with more, let's say, higher level abstractions like this, the primary adapter thing, or for example, the payment thing here in primary adapter. There's a controller. We should be able to go into the application hexagon, and then we have aggregate roots, for example, 3 in here, right? So that's just a prototype. The team is going to work on, if you, let's say, trigger the open type dialog, and then you basically start just typing controller, and then you get all the controller nodes and what have you. So basically revealing these concepts, these higher level concepts, and making them part of our day-to-day interaction with our code base. Right? We're thinking about being able to trigger more advanced code generation. For example, when you say, let's say, go to the aggregate root node and you say, right-click new aggregate root, and then create the aggregate root, the identifier, the unit test, the repository, the integration test for the repository, and what have you. The nice thing about this is that it's extensible. There is, for the predefined stereotypes, there is a JSON dialect that basically describes, here is a concept, a stereotype, basically, and there are certain code assignments, and you can actually go ahead and, in your own projects, you probably in your projects have already some kind of terminology that's specific to your domain, or to your broader domain, to your team maybe. You can just go ahead and say, we define a new stereotype ourselves, right? So this is kind of the DTO. We just want to see DTOs everywhere, and then just add the stereotype annotation. And that will cause, once I go ahead, and that's the only real demo I have for you. Oh no, it's already implemented. So it's basically, it should be a primary port, right? In the payments, no, primary adapter. There we go. Let me just briefly disable the hexagonal stuff, but we should find the DTOs here, right? So it's it's in here, and if I remove that assignment, then it's just gone from the thing here. So you just naturally enrich your code base with these higher level concepts, assign them to, if you want to use hexagonal architecture, then use those things in package info here. Oh, that's not in there. There should probably a primary adapter here, right? And that's why the node actually showed up when I activated this thing here, right? So that's why we have the primary adapter here. All right. This can be tried out with the preview version of the Spring Boot tooling. The IntelliJ folks are working on something similar. They definitely have already the Spring Modular support, so you get support for the verticalization. And with that, where is that other window? It's gone. There it is. Ha! With that, thank you very much. Enjoy the rest of the conference.